Hello and welcome to a math workshop from the University of Oxford, part of our virtual open days. My name's James, I'm the admissions coordinator for maths at Oxford, and this is going to be a math workshop where we look at some math questions. Great to have you with us. I hope the stream's working. I hope I've plugged things into the right places and you can see me in the top corner, see my incredible slides, and also hear me as well. Obviously I can't see or hear you, so the way you can get involved while we're live here is over in the Slido. So during the open day we've been running an admissions Q&A Slido, which if you're on the open day pages further up, there's a Slido Q&A there. We're going to use that as a sort of live chat, so you can type anything in there that you want me to see during this live math workshop. You can ask me questions, don't have to wait for the end, interrupt whenever you like. I really like these kind of anonymous Q&A things because you can ask anything you want to at any point whenever you want to. Okay, right. I'm also going to run a couple of polls, like a vote. We're going to look at some multiple choice questions and I'm going to get you to vote on what you think the answers are. So that's going to appear somewhere in the Slido thing on the website as well. I think it's possible to open the Slido in a separate tab or on a separate device if you want that up at the same time. People who've been watching the Oxford Online Maths Club will know that sometimes I've got it on screen as well. I haven't got that set up today, but we're going to try and do that interaction. So Matthew G is here. Hi Matthew G again. Good to see you. I should say at the start that this is the same math workshop that I did yesterday. We're running it again in case anybody couldn't be here yesterday but is here today. It looks like there's quite a few people here again today, so we're going to run this back again. Hello to George as well, who I am. Raphael, I'm recognising some names from other live stream things as well. More about those in a minute or at the end. I think I've got an advert slide for other projects that we do throughout the year, so if you're joining us for the first time for a live event, then great to have you with us. We do other stuff like this. I will take the opportunity to mention it at some point, so I'm going to shout out hello to Alice and also an anonymous person. So you don't have to put your name into Slido, you can be anonymous and then you can say whatever you like for the questions. It's not going to come back to you. Hi to Fermat as well. You can put in somebody else's name. I think that might be against terms of service for Slido, but Mew and Fermat here, and Olivia's here. Hi Olivia. I think there might be several Olivias. Who knows? Okay, Matty. People are signing into Slido now, so it's kind of thing. Have a minute. I'm gonna read out everyone's name because there's quite a few people here. Hi Freya. Hi Matty. Right, cool. And people are asking questions as well about extracurricular activities. So one's not related to the course. Extracurricular activities not related to the course are not considered by Oxford for admissions. I don't know if the person who asked that question is watching live, so I'm going to type that as well at some point. Right, okay. Hi to a chicken and Freddie, another anonymous person. Somebody who wants to do M-Math Phys. I'll answer that question by typing, I think. They want to do M-Math Phys, which is a master's course. Right, okay. Should we get going with some maths? Well, let's think about what math is first. If you've made it this far to the math workshop, then maybe you already know what this stands for, but just in case. So the M stands for mathematics, which is what we're all interested in. The A stands for admissions, which is part of my job to do admissions. And T stands for test. This is a test that we use for mathematics admissions at the University of Oxford. It's a maths test with tricky questions on. Something that you'll notice today if you're looking at questions is that the questions are really hard. They look really tough. They're not like questions on A-level, perhaps, where you know what you're going to do as soon as you see the question because you've seen 3 like it before. The questions are supposed to be unfamiliar and you're supposed to get stuck because something we're testing is whether you can get unstuck on the question, to have an idea and to turn it into something that you know how to do. Somebody says, how do I get into the math workshop Slido? And you're in the right place. There we go, that'll do. Cool, right, good. Am I in the right place? There's somebody else? Yes. Okay, just gonna hang on. Just making sure we've got everyone in the right place together. A little bit of admin. There we go. Hey to Stanley as well. Right, cool, okay. There's a separate video that I pre-recorded with some advice on maths, and I pre-recorded that one to make sure I didn't forget anything. I also dressed up a little bit more smartly for that video. So if you haven't seen it already, or if you don't know what the maths admissions test is, there's a video called Math Advice, which if you're on the Open Day website watching this on the Open Day website, I think is there, somewhere above. And it's got information about what the math is, what the format is, what sort of maths is involved. The short answer to that is it's a little bit of multiple choice and some longer questions, and it uses just the kind of basic bits of maths from the start of year 12 single maths if you're doing single maths in 2 years. Really restricted syllabus of maths. Hi to Violet and Lara, sorry. Format of the mat, yes I know, and Fermat is here as well, so it's all very, very good. Is this the right place right now? Is everybody going to ask, is this the right place? Right, okay. You get it, you're in the right place as well. There we go. Everyone's in the right place. Well, that I've checked so far. Hang on, let me check the other one. No, good, right, okay. Somebody's in school. Holly's in school, right, okay. You're watching in school. Right, hi to Holly's school. Okay, that's a math advice video with kind of information about what the mat is. There's also a mat website, which I'm going to link to in a moment for information on the mat. I'm just kind of stalling before we look at questions. The big takeaway from that video is my 5-step plan for preparing for the mat, which I'd like to run through very quickly. You can also watch the video if you want to see me go through these steps. There's a very limited syllabus that I've just mentioned. There are some practice questions associated with the syllabus. So I wrote these kind of 2 sides of A4 of just some questions based on the syllabus maths for you to check whether you know the syllabus maths or not. They're designed to be a kind of litmus test, so that if you can do the questions, great, you know the maths on the syllabus. If you haven't learnt the maths on the syllabus yet, then you'll find that there are some of the practice questions that don't mean anything. They're just complete nonsense to you. So it's that kind of test to check what's going on. I guess then, after you've done 1 and 2, short and long questions, that's what we're going to be doing today, which now that I look at it doesn't make total sense, right? Because we've got 1 and 2 and I'm going to do 3 and 4 today. We're going to look at some questions. And then step 5, which looks like a joke at the end, is not a joke. It's the stop doing maths and do something else. The reason for this is that Matt has this very limited syllabus. We're just testing. Let me draw a diagram. Sorry. So if you're doing maths and further maths in parallel like this across year 12 and year 13 like this. This is time in this direction. These are separate. Then by the time of maths, which is somewhere here, you will know this much maths. It's kind of like loading bars on your maths and further maths. But other people might be doing maths and further maths like this. So they only know this much maths because they haven't started further maths yet. So that means when it comes to writing mat questions and the syllabus for maths, we can only use this bit, this kind of first half in here. No, is that right? No, I can use all of this bit, but not that bit. And I can use all of this bit, but not that bit. Okay? So I can use the first half of maths. That's the kind of common half of maths that's in both. Plus, we also use a little bit of this bit, because math is actually, the year 13, year 12 boundary is slightly to the left of the mat time. I've overthought this diagram way too much. Okay, there's a little bit of second half of A-level maths in there as well. Anyway, the point is, the reason I've drawn this diagram is because if you're in the first case, then you will also know all of this maths. And if you're in the second case, then you also know all of this maths. So in step 5, you should stop doing maths and practice some of the purple maths instead. I'm going to try out some other bits of the maths that you know. Practice tricky questions with that. Revise it. Have a look at other bits of mathematics. If you're not doing A-levels, if you're doing some other qualification, that's fine. I'm sure there's other bits of maths that you know about that you might want to practice. There's just more to life than math questions. Right, that said, let's do an hour of math questions. Okay, math website for the syllabus practice questions, past papers, worked solutions, videos of me doing the last 4 years of papers quite slowly. There are histograms of people's scores, statistics about averages, basically anything you could want about math papers is on www.maths.ox.ac.uk/r/mat. Hi, shout out to Euler and Gödel, people are taking all the mathematician names, Ayana and Siam. People doing IB should not be at a disadvantage. I've drawn the A-level boxes because most of our applicants, or quite a lot of our applicants are doing A-levels. People doing IB shouldn't be at a disadvantage because the mathematics used on math is pretty limited, pretty basic. It should be an IB as well. You should have seen it by the time you do maths. I know that if you're doing IB, then you only have one maths thing. You don't have two maths things, but we're not using the second maths thing. Anyway, right, you should be fine. Okay, have a look at the syllabus and decide whether you've seen that maths. Show it to a teacher if you want to. Decide whether you're going to have seen that maths. Tenses. Right, okay. Is this a math question next? Yes, here's a math question. Brilliant. Okay, so this is a short question. I've picked this one because I can think of more than one way to do it, which is not me showing off. I like a question where there's lots of different approaches. It is old. It is from the olden days of 2009, and back in 2009 we wrote the questions using radians. These days we write all the questions. We write the questions that use angles. We write the questions using degrees. We don't assume that people have seen radians anymore. So we write them with degrees. Now, of course, you're welcome to use radians when you answer them if you want to use radians, but we use degrees to phrase them. So I've just updated this question for 2021. Is it worth practicing radians questions? So if you don't, even though I don't use radians anymore, so if you know about radians, then you can understand all these past questions that use 2 pi instead of 360. Some of them are very radian specific. There are a couple of cool graph sketching ones which only really work if you imagine them in radians. So if you know about radians, then sure, there's some extra cool questions. If you only know about degrees, then some of these past questions don't make sense to you. In the table of past questions on the MAT website, I've added a column of notes. Notes is a column next to feedback. It says notes. If you click it, you get a quick report of which questions from that year used radians or were weird in a different way that would no longer be on the MAT syllabus. Okay, this is 2009 MAT MCQ. Yeah, 2009 MAT MCQ something. 1E. Yeah. I assume that's someone recognising the question and not realising that the name is written at the top of the page. Right, okay. I'm going to switch on a poll in Slido so that people can vote for how many solutions they think this has got. I haven't read out the question yet, which is rude of me. Anyway, I was talking about degrees. Here's the question. In the range 0 less than or equal to x less than 360 degrees, the equation, horrible equation, has, and you think the options here, we're supposed to complete the sentence. So does it have 0 solutions, or does it have 1 solution, or 2, or does it hold for all values of x? So these are kind of alternatives. On the multiple choice questions, there's 1 correct answer and all the others are wrong. And actually, since 2009, at some point, we started giving you 4 wrong answers instead of 3. So we upped it to choosing from 5. This question is so old that it's back from when we were just doing 4 options. Now we do 5. Okay. Aha, Sam in chat I can see, right, Sam has posted a solution. I'm going to hold it back just a little bit. And it's a good point for me to remind people that MAT is not a calculator test. You cannot use a calculator in the MAT. So if your plan for finding solutions to this is to type it into your equation solver calculator and the calculator will say beep boop, there's 2 solutions, then that plan's not going to work out. We need to do some maths, I think, on this. Sam, I'm going to hold that back just a moment to give other people a chance to think about it as well. Oh, and I see quite a few people have voted already. I'm doing the vote secretly. It's also not on the screen, so if you don't want to see it, you can't see it. And there are 2 options that have got about 50% of the vote each. They're doing really well. And they're complete opposites of each other. Okay, right, good. Voting going on over there. Yeah, okay. So when I see this equation, I was trying to say before that MAT questions are quite often, you won't know what to do straight away. So here, 2 to the sine squared plus 2 to the cos squared equals 2. I have never seen that equation before. I don't have a formula like the quadratic formula for solving equations like that. It's got a sine squared in. But maybe watching at home, you've already spotted something, or you've had some sort of idea about how to make progress or how to get started. Because of the sine squared, I think, and the cos squared. And I quite like this method of getting unstuck, where none of the options are crying out to me that, the answers we could get all seem pretty strange, and I can't really see how we're going to get there. But from this starting point, I can sort of see a way to start exploring, to start trying to manipulate this expression to find out what's going on. Ah, yes, brilliant. Someone did this question recently. You could put them together. Aha, you could, an anonymous person has also typed a solution. So something someone's just said in chat is that sine squared plus cos squared is equal to 1, which is true. And I think I can see people in chat getting excited about that. And actually people have voted for one of the options, which makes me think people are getting excited that, aha, we've got sine squared plus cos squared is 1, so 2 to the sine squared plus 2 to the cos squared, aha, 2 to the 1 is 2. This is all looking very suspicious if I put a 1 up here, right? But sadly, powers don't work like that. Let's not get carried away. If we want to do 2 to the power of something, we can't just do this. This is not equal to this. Annoying, okay? Right, if we've got these powers added together, we can't just add the upstairs indices together. Exponents, we can't add the exponents together. That's not how powers work. I think I might have tricked people a little bit. People who voted for D. If you voted for D, maybe it was because you thought that, well, if you get carried away or do this too quickly, then you might add the powers together. Maybe. It would work if it was a multiply sign. If it was 2 to the sine squared x times 2 to the cos squared x. Someone in chat saying they were here yesterday, so they've already seen this question. If it was that, then that would be 2. That would be true. But unfortunately it's a plus, not a times. Okay. Oh, somebody wants to rearrange it. Oh, yes, okay. Brilliant, yes. Okay. Right, okay. I've approved a lot of chat messages. Sam was in there first. Okay. So, an idea from elsewhere in chat is to, let's use this fact. This fact is still true. Sine squared plus cos squared is 1. Let's use it more carefully though. So we're not gonna just 2 to the each term in the equation, because you can't 2 to the each term in the equation. But we could take this equation at the top, 2 to the sine squared plus 2 to the cos squared, and we could rearrange it as something like, what does chat want me to do? Chat had a suggestion in here. Discriminants, quadratics. Yeah, I'm going to go with that one. To rewrite this sine squared as 1 minus cos squared. It's 2, because this is the equation. I almost got confused that 2 to the 1 might not be 2. That was a very confusing moment. Okay, why is this a good idea? Well, we can now use some laws of indices, being really careful, to write this as 2 to the 1 divided by 2 to the cos squared x plus 2 to the cos squared x is equal to 2. And then we've got an equation which has got horrible variable down here involving x, same thing involving x over here, and plus sign and some 2's. So if we write something like u as 2 to the cos squared x, then we've got 2 over u plus u equals 2. Oh, and that's a quadratic equation. And now I can relax. And this happens quite a bit with math questions, that you see it, it's scary, I've no idea what to do, and then you explore a little bit, you manipulate the things in the question just a bit, just out of exploring. I don't know when I'm doing these steps where this is going to go. But then sometimes it snaps into place, and you can relax a bit. You've got over the tricky bit, relax a bit. Quadratic equations are relaxing, right? Because we know loads of facts about quadratic equations. We're not going to make any mistakes manipulating this quadratic equation. Okay, so this one is u squared take 2u plus 2. Now I've said I'm not going to make any mistakes. This one rearranges, I think, to u minus 1, sorry, squared plus 1 equals 0 or something. Rearranging and completing the square or something. Boring stuff. Okay, so that has no solutions. Yeah, multiply through by u, see Anne's got it. Could we use, so George wants to do Alice's. Yeah, Alice has got a different solution that I've seen other people say as well. I'm going to read out Alice's one in a moment. See what says this. Yeah, Matthew G says it, but Matthew G, you were here yesterday as well, right? Or unless it's a different Matthew G. Okay. George wants to do logarithms on both sides. I think that's tricky because if I take a logarithm on both sides, then on the left I'll get something like log of 2 sine squared plus 2 cos squared. I don't really know what to do with that. I mean, maybe I can do some more maths afterwards. Okay, Alice has got a different approach. Let's clear this and start again. Alice has got a completely different approach, which I'd like to read out. I like the way there's different approaches to these questions. Alice says, what we need is for sine squared x and cos squared x to both be 0. So I think Alice knows that sine squared x and cos squared x are both bigger than or equal to 0 because they're squares. They're squares of things. Squares are always positive or equal to 0. So this first term is going to be greater than or equal to 1, and also this second term is going to be greater or equal to 1. Aha! So, and in particular, they're only equal to 1 if sine squared x equals 0 and cos squared x equals 0. If these things are going to add up to make 2, that's the smallest thing they can make when you add them together. We would need both powers we would need both powers to be 0, and that doesn't happen. So no solutions. Yeah, greater than or equal to 0, so 2 to the sine squared, 2 to the cos squared are each greater than or equal to 1, so their sum is only 2 when sine squared and cos squared are both equal to 0, which is never true, says Ethan. Yes, good. Okay, inequalities as well. So I like that you can use a change of variables and some sine squared plus cos squared facts, so some trigonometry, a little bit of quadratic equation science to solve this equation. Or you can use some inequalities to write down bounds on what the terms are like. Someone's just driven a loud car past, sorry about that. You don't have to show you're working for multiple choice, so someone's just asked me that. You don't have to show you're working for multiple choice, and you don't get any marks for working out. Here you get 4 marks for the right answer, you get no marks for putting the wrong answer, sorry. All marks on the answer, thanks Sam as well. Yeah, people are talking about, so the question about real numbers, shouldn't it say no real solutions? And the answer, I suppose it could say no real solutions. There are no complex numbers on mat, so if in doubt, assume things are asking you about real numbers. It is sometimes a little bit weird that if you know about complex numbers, then I think you can make up some complex roots to this equation, but that's really not what the question is asking about. Okay. Good, right, questions. So, if in doubt, things are real, because, yes. Sometimes we put in the word real into questions, but sometimes that just makes the question really confusing, because if you don't know about complex numbers, why is everything saying real numbers everywhere? It's just a bit weird. Okay. Complex numbers are in further maths, so totally out for math questions. Some people haven't really started that course at the time they take the test. Some people are not doing further maths. Can we use derivatives of each side? No, I don't think we can, sorry. Yes, and also because if this equation is true for one value of x, then we can't differentiate. We're not claiming it's true for all x, so we're just looking for particular values. In general, you can't differentiate equations to find the roots. If you're trying to solve a quadratic, that does not imply that 2ax plus b equals 0. Those are not the same. You can't differentiate. Holly says, can we guess and get 4 marks? Yeah, sure. One of the reasons we added a 5th option, option E, was to make guessing a little bit worse. But there's no penalty for being wrong. So yeah, if you want to, you can guess. You can actually use this to get partial credit, sort of, in a probabilistic sense. If you did some work and you decided that maybe this had either 0 or 1 solutions, so you ruled out these options, but you decided it had 0 or 1, but you weren't sure, and you were running out of time, then you could guess between those two, which is quite a sort of mathematician skill, right? To use some of your knowledge to eliminate options. And then, in a probabilistic sense, your average, the average if you do that on every question is you get half of the coin flips right, so you end up with, on average, 2 marks out of 4. I don't know why I've said all that. Yeah, there's no marks for working out, but if you guess, then sometimes you get marks where you would have got method marks. Anyway, right, multiple choice questions, just marks for the right answer. There we go. For the longer questions, which we're going to look at in a moment, there are marks for working out, there are method marks, there are explaining marks that we're going to get down to in a moment. Right, okay, how did that live poll go? Oh, the live poll was very successful. Right, good, okay. Well done everyone watching and sliding. Okay. How are we doing? Oh, people are replying to each other's questions, which is very nice. Thank you, people putting nice and friendly answers to other things, because I can't type while I'm doing this at the same time. Okay. People so far are putting true answers as well, which is very good. Okay. If you get an answer from someone and it doesn't look true, then please don't. Okay, right, good. Okay, please don't. Right, okay, that was a short question. We've got 4 marks. We're doing well. Here's another one. Yeah, so it's 4 marks or nothing for the multiple choice questions. There are 10 of them, so you can get up to 40 marks on multiple choice questions. Yes, and a friendly person has put yes underneath. Thank you. Right, good. Okay, switch on a live poll for the new question. This is a question about a polynomial. And it's a horrible polynomial. Look at this one. N squared x to the 2n plus 3 minus 25n x to the n plus 1 plus 150 x to the 7. And the question asks, when does that have x squared minus 1 as a factor? Is it for no values of n? For n equals 10 only, for n equals 15, or for both of those values, 10 and 15. Oh, power rule. What's the power rule? Is that combining? I can't remember what the power rule is. Power rule is something about combining together powers, isn't it? So that x to the 2n plus 3 is the same thing as x to the 2n times x to the 3, which is nice. We've got an x to the n plus 1 as well, so we could do something over there. It's true. Ethan and Sam have got a suggestion in chat. I'll read out in Mo. I'm going to give people a moment to have a go at getting started with this question. So we're in that stage, by the way. I've put a box around it, but I'm pretty clueless here that it's a hideous expression. The powers, I don't even know, is this a quadratic? Is this a cubic? Probably not. It's got an x to the 7 in, but also because it's got these other mysterious powers of x to the 2n plus 3 and x to the n plus 1. So this is a pretty weird polynomial. Freddie wants to try all the options. So I guess here all the options would be try 10, try 15. Okay, so you try this plan over here. So try 10, so try n equals 10. If you try that, then what you're doing is you get something like x squared to the 100 times x to the 23, plugging in n equals 10, minus 250 x to the 11, plus 150 x to the 7. Oh, and then we've got to decide whether x squared plus 1 is a factor of that. So here's the question, is that times 100x to the 19, but then I get a minus, so I want to minus 100x to the... Oh, I'm not enjoying this. So maybe we could. I think this term I'm working out over here has got about 10, 11 terms in, maybe 20. It's got quite a lot of terms in, so I'm probably going to make a mistake in there somewhere. In fact, I already have, because 23 take away 2 is 21, not 19. I don't trust myself to do that polynomial division. And people have got suggestions about other approaches, which I'm going to read out now. Somebody with the username SV says we only need to check 1 and minus 1. Yeah, Wario says x squared minus 1. I won't do a Wario sound effect. X squared minus 1 is very surprising, says Wario, because that's x minus 1 times x plus 1. Difference of 2 squares. I love the difference of 2 squares. I love the way it turns up all over the place. This is perhaps the least surprising place for difference of 2 squares to turn up in a question about polynomials, but never mind. Difference of 2 squares. Brilliant. Yeah, okay. People are wondering about 15, about odd numbers. Yep, okay. Yep. Okay, right, good. Factor theorem. Quick revision on the factor theorem, because I don't know if everybody knows the factor theorem. So the factor theorem, people in chat are suggesting, says that x minus a is a factor of the polynomial p of x if and only if p of a equals 0. So one way round says that if x minus a is a factor of your polynomial, then when you plug in a, you get 0. And that's not surprising, because that bracket x minus a will be 0 when you plug in a. The other way around is a little bit surprising. There's some good maths hiding behind there. That if p of a is 0, then x minus a is a factor. Okay. Yeah, so people are looking at the different terms. Yeah, telling me that factorizes. Can we use plus or minus square root? Why use difference of two squares when you can just solve that? Yeah, okay, I could just write x squared equals plus or minus 1, and then x equals plus or minus 1. And I just like factorizing, right? I wanted to talk about factors. So this thing is a factor of the polynomial, if and only if both of these terms, x minus 1 and x plus 1, both of those are factors. Okay, and then the factor theorem says all we need to do is here just check if p of 1 equals 0 and p of minus 1 equals 0. That's all we need to do. Factor theorem. Okay, amazing. This question doesn't say factor theorem anywhere on it, but somehow knowing the factor theorem was the right thing to do, I think, because now we're turning this into a question about well, knowing that we've got two equations out of this, which seems pretty good. Okay, two equations, want to get a couple of solutions, seems pretty good to me. Okay, people are going to maybe factorize x to the 7. I don't think I'm going to do any factorizing. Factorizing polynomials is quite slow and I'm quite bad at it. So I'm going to try and avoid factorizing and just work with checking whether 1 and minus 1 work. It probably, if you're very good at polynomial division and working out the powers correctly, then I think you can approach this by dividing the polynomial by x equals 1 in the 10 case, and then also trying the 15 case. 15 case has got even more terms because this power is now like 33. Okay, right, let's check what happens for p of 1. P of minus 1 is 0, so this is what we want. We want both of these to be 0. Okay, so when I plug in 1, I get n squared times 1 to the 2n plus 3 is 1, minus 25n times 1 to the n plus 1 is 1, plus 150 times 1 to the 7 is 1. Okay, that's a quadratic equation. It's pretty good. I think I can guess what the roots are going to be. When I plug in minus 1 though, something different happens. Watch this. X to the 2n plus 3, well that's an odd number in the exponent, so that's minus 1 to the power of an odd number. Powers of minus 1 work that minus 1 to the 1 is minus 1, minus 1 squared is 1, and then minus 1 cubed is minus 1. So they kind of cycle like that. There's an alternating pattern. When you do minus 1 to an odd number, you get minus 1. So this is minus n squared. And then this next one, well hang on, I don't know if n is even or odd, so I don't know if n plus 1 is even or odd. So there's sort of two cases here. One of them if n is even, and one of them is if n is odd. So this term here, this minus 1 to the n plus 1, if n is an even number, then that's going to be minus 1. And I'll get plus. I have to be really careful. If n is even, this is x to the. If n is even, this is something to an odd power. Minus 1 to an odd power is minus 1, so I'm writing plus because there's a minus sign out the front. Whew. If n is odd, then this is an even power, so the power is 1. The power is not even, the power is 1. So this is minus 25n. It's the opposite. Okay, and then the last one, I can't get this wrong, can I? Oh, I have got this wrong. Clip that. Right, okay, I've got these two quadratic equations in different cases depending on whether n is even or odd. Okay, the first one factorizes to be very nice. It says n is 15 or n is 10, which is quite nice. It's one of the options. Option D. Anybody going for D? Anyone going on D? Ooh, some people are voting for D, about a third of people. And ooh, what's going on here? So then the other equations, this first one, I can, at great risk, I can multiply it by minus 1. And then I recognise this one. This is the quadratic equation again, same one as before. Okay, but that's only if n is even in that case. Okay. This other quadratic equation, you see, I've seen a load of quadratic equations now, so I'm sort of happily solving quadratic equations. That's n squared plus 25n plus 150 equals 0. Can I solve that one? Yes. And I think I might have got some minus signs wrong. No, maybe not. I believe in myself. Can I get these minus signs wrong? Is that n plus 15, n plus 10? Okay, so n is minus 15 or n is minus 10. This is just not helpful, right? Because in this second case here, if n is odd, then I would have to take n to be minus 15, not n is minus 10, because that case only held when n is odd. But n equals minus 15 doesn't work in any of the previous any of the other cases for p of 1 being 0, because it's not 15 or 10. Negative 15. Ugh, don't like that. On the other hand, in this n even case, let's put a note here as well. So the n even case, well, if n is 15 or n is 10, but now n has to be even, then I really can't have 15. Sorry. 15 is an odd number, so it's in the other case, where there's a minus sign here. If there's a minus sign here, then, oh no, actually 15 wasn't the solution of that quadratic. You see different quadratics in different cases. So I think that means it's only 10. Only 10 works. What do I do if n is even and odd? Well, I can't think of any numbers that are even and odd, so I'm probably okay. Ali's noticed we've almost made it to 2 to the power of 11 subscribers, which is so many subscribers. We've been slowly climbing up number of subscribers through 6 months of Oxford Online Maths Club. Okay, Ben wants to know about independent projects in maths, which people sometimes do some summer projects over the summer. To do a little bit of extra maths in between the years. There's some information about that on the web. I'll try and find a link and put it on Ben's comment. Okay. Why did I look at whether n is even or odd, says someone. And that's because I was plugging in minus 1 up here, so I had minus 25n, and I was trying to work out minus 1 to the n plus 1, and I wanted to simplify that. You know, I could have just written that equation out with minus 1 to the n plus 1, but I don't know how to solve quadratics with numbers up in powers as well. So I thought, well, okay, there's only really 2 cases, because minus 1 to powers is not that bad. 1 to the power of a thing, that's lovely, I love it, it's always 1. Minus 1 to a power is a little bit more complicated. I've got to think, it depends whether the power is even or odd. So I've split into these 2 cases, for even and odd, because I was thinking about whether this bracket, this x to the n plus 1, was going to be minus 1 or 1. Kind of because I wanted to simplify this a bit more. This is a very complicated thing, and I'm trying to do my best to turn it into a quadratic. Just having it as minus 1 to the n plus 1, really complicated. Having it as over here, having it as a plus sign in one case and a minus sign in the other case, I can cope with. Cool. Oh, Sally's coming to the maths club later. Yes, that's right. We've been running the maths club all year, and we're not taking a day off for the open day. We're doing more live maths later today at 5 PM. Right, cool. Thanks for doing an ad, Sally. Ooh, Sally with 3 L's. Cool. Okay. Right, what am I doing? People telling me whether things are 0 or not, and I've got scared. I think I'm okay. Right, good. Answers B. How did chat do? Oh, chat did pretty well. About 2/3, 1/3 there. Okay, good stuff. Right, should we do a long question? Let's have a look at a long question. Got about 20 minutes left on the workshop. Here's a long question. There's lots of reading to do. We're going to spend longer on this one if we can, I think. In the actual test, we would definitely spend longer on it. I'm going to circle stuff and talk about the structure a little bit. You're welcome to read ahead and start trying to do the question if you want to. So there are these parts to the question, little bits and pieces. So I, V, and some of them link together. For this particular question, part 1 links to part 2, part 3 definitely links to part 4, and part 4 definitely links to part 5, but parts 2 and 3 are separate. Now, I only know that because I've read the question before and I've thought about it and I've realised what's going on with the question. When you first see a question, there's no way to know whether the parts are going to be linked together or whether they're just separate ideas. So what does that mean? I guess that means that sometimes you need to have done the previous part of the question, but sometimes you don't. I mean, in fact, even if the parts are linked together, sometimes there's something like a show that over here. So down here we've got show that this equation, and then I can see in part 5 says when a is 3 over 4, blah 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 blah. So maybe I could start thinking about part 5 now if I wanted to. I haven't read the first 2 parts out. I haven't read them out yet. But maybe I could start thinking, well, when a is 3 over 4, I would have something like 3n minus 1 n plus b bigger than or equal to 3 over 4, 4n minus 1 times n. That's quite an interesting equation. In fact, that looks like quadratics on both sides. Maybe that bit of the question's okay. You see, so reading through or looking at the different parts of the question can help you understand that bit's going to be hard, that bit's going to be easy. We don't put how many marks each part of the question is worth on the paper because we want you to. We don't want to tell you which bits are the hard bits and which bits are the easy bits. Who knows? Right. Okay. Quick look at chat. Is it on the same? Is the Maths Club on the same YouTube channel? Freddie has a yes. Freddie's correct. Also on the Oxford Mathematics Plus YouTube channel, which is where we are. I think if you're on the Open Day page, if you're watching the thing on the Open Day page, and it's perhaps not clear where we are on the internet, but yes, on the same channel. I'll put a link up in a bit so that people can find Maths Club fun. Okay, right. Let's read this question. I did this yesterday as well, and I thought it was quite fun, so I'm going to do it here. I'm going to circle all the instructions in the question. I'm one of those people who likes drawing all over questions. Right, okay. For a positive whole number n, we're given a function fn of x. So we're supposed to understand that this is like different functions for different numbers. So there's an f1 of x, f2 of x, and f3 of x, and so on and so on and so on. And the different functions have these different values of n. This is a little bit like the notation that's used for sequences. So if you've seen sequences like a1, a2, a3, sequence of numbers, this is, I guess, like a sequence of functions. But it's not important that you realise that or understand that. We're not going to do anything with sequences in this question, I think. Cool, okay, so we've got fn of x, and we've got some definition. It's equal to x to the power, more powers of x, minus 1 all squared. Okay, instructions are here. Sketch the graph. We love curve sketching. We love getting people to sketch things. There's loads of things that you can check on a curve sketch. You can check, for example, here we're asked to label where the graph meets the axes. So where is it 0? Where is it across the y-axis? Here I think when x is 0, this is going to be 1 squared. 1 squared is 1, so that's going to cross the y-axis at 1. And then, okay, so that's part 1. Just draw this function we've given you. Part 2 wants us to sketch the graph of fnx when n is a large positive number. Okay, so if n is a huge positive number, like 7 or something, then what does this graph look like? Or a million. What's a big number? Okay, so we're going to have to think a little bit there about what sort of values this is going to take if n is a huge, well, I suppose we could say when this is a huge power of x, what's this going to look like? For example, I think it's still going to go through 1 on the y-axis, same y-intercept, because whatever this power is, when I put a 0 in here, I'm going to get 0. So this is going to be 1 squared equals 1, again, whatever the power is. So it's kind of interesting. Some things are going to be the same when I put in a big integer like 7, and some of them are going to be different because I think the shape of it is going to be a little bit different when n is a huge number. Okay. I'm not going to draw that yet. Maybe if you've got a scrap of paper handy, you can have a go at sketching that now. But I'm going to read on to look at what's going on in the rest of the question. Now, I told you there was going to be a jump or a kind of change of focus. So we've done some graph sketching. Maybe we'll come back to that. Maybe not. Next part of the question just wants us to determine this integral. So we're going to need to have an idea of how to do this integration. We're integrating fnx, which is that thing at the top. It's a square of a combination of polynomial terms, I guess, and maybe we'll have to think a bit about how to do that integral very carefully from 0 to 1. Okay, but that's completely separate, right? We did our curve sketch. Now we're going to work out an integral. Okay, bit of a change. Part 4 is kind of almost a break. It says the positive constants a and b. For some reason, positive is in italics, it's emphasised, are such that, now, okay, so these are some numbers such that for all n bigger than or equal to 1, this integral that we just worked out is less than or equal to 1 minus and then this a over n plus b. Okay, so this is some inequality that's true for all n, and it involves some numbers a and b. Okay, so I don't know what a and b are yet. I think we're going to work out some stuff. Anyway, the question wants us to show that something, and later explain why something else. And this is quite normal for long questions where earlier on we're getting marks for just doing the integration. So we get some method marks perhaps for knowing how to do integration and an accuracy mark for getting the right answer. Up here we might have got marks for drawing the graph that looks about right and for getting the accuracy of the crossing points right. But down here for the show that or explain why, we're going to need to add in at least a few words to explain why something is true. To explain why this thing. It's not enough to just write this down because it's printed right there on the page, so you can't get a mark just for copying it out. We're looking for an explanation of why this is true. We'll probably have to do some maths along the way, so it's not just, it's not just debating or arguing or something. There's going to be some maths to justify it, but encouraged to write a few words just to show what you're doing. Good question over there. We're also going to explain a is less than root of 3 over 4. Last part of the question just says special case when a is equal to 3 over 4. They want to know what is. So like find the smallest possible value of b. So some inequalities or something over there. And we already had this idea that maybe we could plug in the a and rearrange or do something quadratic-y over there. Alicia says, when sketching graphs, should we also show local minimums or maximums? And I think I'd say if they're easy to work out or if they're obvious, then sure. Yes. If they would involve doing lots of calculations, then maybe not. Usually, if we want you to calculate the position of a local minimum or maximum, or of a turning point or something, then we would probably ask you to, just to make sure that everybody remembers to work out where it is, so that we've got that clear instruction in there. Here, we're not asking for location of the turning points. In fact, for this particular graph, it turns out to be quite obvious where the turning point is. We'll do the sketch in a moment and point at the turning point. In general, for maths, there's not very much that we expect people to be able to differentiate. In the differentiation section on the syllabus, it's kind of just differentiate polynomials and differentiate e to the kx. It's the only things we think you know how to differentiate by math, because you probably know some other maths as well, but those are the only things we're going to assume for math. Here, I suppose this is a polynomial. Maybe you could differentiate it. It turns out the turning point is, I would not differentiate this one. Maybe that's personal taste. Okay. If you're asked for turning points, go for it. If not, then consider it briefly. If it feels like a lot of work, I would do something else instead. Okay, right, good. For large positive integer, should we think of n as n approaches infinity? I suppose you could, if you wanted to. I would worry a little bit about... Yeah, well, n is a large positive integer, just means n is an integer that's large. It doesn't necessarily have to mean something about limits or what happens when n is infinity. I don't know what happens when n is infinity, and I'm not quite sure it's relevant. Maybe it's kind of a little bit related, but no, yeah. We don't expect people to know... There's language in there a little bit about approaching infinity or limits. We don't expect people to know about limits for this sort of thing at MAT. Okay, right. Should we have a go at doing the question? Is that what people want to see? We've got about 10 minutes left on this workshop, so I could just leave you with this, or I could try and do some of it live on screen, doing some MAT questions. How about this? If people want to ask questions about MAT or ask about something I've said already, then you can ask a question in the Slido. If nobody asks anything, then I'm just going to start sketching that graph, I think, because I want to have a go at it. Might do the integral, might talk about some inequalities. Should I do that? Yeah, okay. There's a little bit of stream lag, which gives me the advantage that I can start sketching graphs. But if you want to interrupt and ask a question, I think I can multiple choice. Oh dear, that's a bad start. I think I can multitask. What's irony mean? When you're trying to multitask and can't even say the word multitask. Okay, so in my head I'm imagining f2x, well, that's just what happens when n is 2. So that's x cubed minus 1 squared. Don't need to draw in. Oh, I see. There's going to be a discussion about whether we draw. Okay, part 2. We're going to do part 2 because somebody's asked a question about part 2. Sorry, in my head, I'm imagining x cubed minus 1 and then squared. So I'm trying to imagine x cubed minus 1. That would be a graph like, so if this over here is x cubed minus 1, that's what cubes look like, right? Comes in and then it blows up like that and it goes through 0. If I square that, then when I square numbers they become positive, and if they were bigger than, if they're bigger than 1 or less than minus 1, then their magnitude gets larger. If I square something that's between 0 and 1, its magnitude gets smaller. But what I'm really thinking about is the fact that this goes through 1 minus 2, sorry. Where does that go? Anyway, maybe it's not important because I already know, hang on, that this is minus 1. Minus 1 squared is 1. So it's going to come through here and then boop. Because near here it's going to get down to 0. Because when you put in 1, you get 1 to the power is 1, take away 1 is 0, that's squared. Also, this thing's always positive because it's the square of something. So this is going to definitely have a turning point here. And I don't need to do any calculus to work out that it's got a turning point here. It's a thing that's always positive coming down to 0. So it can't go past because it can't go negative. Okay, right. On the same graph, I'm going to try and draw x to the, let's do x to the 15 minus 1 or something. So a large power of x. I would draw that as something steeper, I think. So it still goes through here. Still goes through here. So x to the 15 is just a bit more violent, a bit more excitable, isn't it? When x is 1, this is 1 to the 15 take away 1, which is 0. When x is 0, this is minus 1. And then x to the 15 just gets really big, really, really fast. Okay, so let's do... What is that, by the way? That's f8. Which is going to come down from really large to very suddenly being, what's this crossing point over here? Is there some interesting point over here? I'm not sure. Yeah, so when x is between minus 1 and 1, what happens for minus 1? So for this first one, it was minus 1 cubed is minus 1, take away 1 is, is 2 squared is 4. There's a point over here, it's sort of minus 1, 4. And now minus 1 to the 15 is minus 1 take away 1. It's going to go through this point as well, isn't it? Up here at 4. Okay, so really steep, comes through, and then it's going to be a bit weird because this is very sort of flat because all these numbers, x to the 15 is going to be close to 0. If you take the 15th power of something that's between minus 1 and 1, you get something really small because every time you multiply, you're multiplying by something less than 1, so it gets smaller. Okay, that's going to come down to 0 very sharply because this is very steep, very sharply, and then go up very fast like that. Okay, I think I've got some interesting points on there. So I've drawn this a little bit curvy because for any particular large positive integer, this is a nice smooth curve. So I've put in n is 8, and I've got this a curve a bit like this. For any particular large integer, it's going to have kind of a curved shape to it. We're not being asked for the sort of limit because we don't know about limits. And I think people in chat are talking about whether it's curvy or not. And for any particular large integer, it is a curve with smooth curved bits. It's true that the larger you make the integer, the more sharp it gets. I think if you're imagining something like x to the 101 or something, then the graph is basically like 0 between minus 1 and 1, and then up to really big numbers really quick. But it's not quite like sharp right angled corners because 101 is not infinity. Anyway, do we need to show that before x less than 1, 0.26, y is similar to 0? I don't know what 1.26 is. What's the relevance of 1.26? I don't know. I think Yeah, okay, good. Right, I've got my sketches. How are we doing? We've got 5 minutes. I'm going to do the integration really quickly as well. So here's sketching different polynomials. That's a skill. It's 2 to the 1/3. That's at 2 to the 1/3. 2 to the 1/3, you get 2 to the 1/3 gives you 1 in that one. So that's this point here, is at 2 to the 1/3. I think. Where it's at the same level as that one. Don't think the other one does anything at 2 to the 1/3. I'm not sure y is similar to 0 inside there either. That's where y hits 1. I don't understand this question. Sorry. When x is 2 to the 1/3, y is equal to 1 in one of the cases, and y is incredibly large in the other case. Yeah, confusing. In the limit, it's like a 4. Oh, right, like a numeral 4. In the limit, it's like dup, 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 dup. Like a big number 4. Yeah, sure, okay. With some horizontal lines. You're not stupid. You just found a number and then it didn't quite mean the thing you thought it was. Right, okay, good, right. Positive thinking. You watched me miss all my minus signs earlier. Right. Okay, let's do some integration very quickly and then wrap up. Because, oh, it's getting late. It's not getting late, it's only 3 o'clock. Okay, I'm going to do the integral really fast. I'm going to do the integral? Yeah, okay. So, Matt, we don't expect you to know complicated things like the chain rule or the product rule. We don't even expect you to have heard of the chain rule or the product rule. All we're looking for is, here, can you multiply out this? And then integrate. Because we do expect you to be able to integrate polynomials like that. If you do that, then you get this. Okay. And then we need that in some inequalities later. This 4n minus 1 in particular is going to be really interesting later on in this. Later on, we're going to get this 4n minus 1. And in fact, getting to this inequality is a way to check that we did the integration right. Okay, we're going to rearrange this. We're going to take our result for the integral, plug it in here, rearrange to get up to that inequality. Okay, and then explain why a is less than or equal to 3 over 4 is I think that comes from thinking about what happens when n is very large. Big N again. Okay, good. Some inequality stuff at the end. When a is 3 over 4, I think the smallest possible value of b, it comes from plugging in 3 over 4 and rearranging the equation. So it's not actually hard to do. I like it when the last part of the question is just sort of, sometimes it's not hard to do. Sometimes it tests whether you understand the whole question together, and sometimes it doesn't. Okay. Is there nice notation for the integral of f? What do you mean, like integral of f? It's pretty nice notation, isn't it? A bit like f prime x. Some people... Oh, okay, yeah. That is nice enough. Like f prime. Somebody wants a different notation for integration. Invent your own in the Slido chat now. Right, okay. I'm going to do a couple of quick ads. Thank you for watching Matt Workshop. Thanks for watching me attempt some Matt questions. If you'd like to try some more, they're on the Matt website. There was a link before and there's a link in the YouTube description. Other things that we do, like this, for doing live bits and pieces of maths. We're currently running something called the Oxford Online Maths Club. The website for that is, let's do a little advert very quickly, www.maths.ox.ac.uk/r/club. That's the Oxford Online Maths Club. That's got supercurricular mathematics, so bits of mathematics not related to the maths that you learn in school. Sometimes university maths, sometimes talking to our current students, sometimes just bits and pieces that I think would be interesting. We're doing that every Thursday. We've been doing it every Thursday this year. So there's an archive now of 23 episodes available to stream on demand, I suppose. They're YouTube videos. You can watch them whenever. We're also live today at 5 PM for episode 10 of season 2. I'm going to be talking about some counting problems that I've collected together. So we're going to be doing some counting today at 5 PM. That's going to be on this channel as well. If you go to that website, then you get a link. If you head over to this YouTube channel, then you get should be able to find the live stream depending on whether I've set it up or not. Also, starting from the 5th of August, if you've enjoyed seeing some Matt questions happen, we're going to start the Matt live stream. We ran this last year and we're bringing it back this year with slightly upgraded stuff. So the Matt live stream is a collection of live events looking at solving math problems like this one has been. We're going to build problem solving skills. That's at maths.org.uk/r/matlive for live stream math stuff. There's a link through from the club page. There's a link through from the maths page. So over there's going to be bits and pieces of math resources. This is going to have a weekly live show and also some resources for you to try out before and afterwards. Preparing from the syllabus maths, trying out some questions, some extension material, some of that kind of maths club fun of looking at other bits and pieces of mathematics. This is kind of the next upcoming project. That's going to launch on the 5th of August after this season of the maths club, and then a little break, and then Math Livestream kicks off for August. That's going to run over the summer, so if you're looking for something to do this summer, then I hope you find other options as well. But if you really want to, you can join us on Thursday as your summer entertainment on Thursdays at 5 for some math questions. Thank you very much for watching today. Thank you for joining in with the questions and the polls and coming up with suggestions and things in chat. It's been lovely to do some maths with you. I hope you enjoyed the rest of the open day. I'm going to be hanging out in the Slido for another hour, answering questions from the open day. I know I missed some earlier from people asking questions in the chat during the workshop, so I'm going to go back and answer those now. If you're hanging around, I'll see you at 5 for Maths Club. Otherwise, maybe on some other project, or have a nice afternoon, and thanks for coming along. Right, okay. People who've seen the Maths Club know that I'm very bad at ending live streams. We're going to do this. It's going to be great. I'll see you around. Take care. No, hasn't happened. Still here. Bye.